welcome back to another episode of the Envisiontech podcast. I'm your host, Paul Gagan, and this week we're going to talk about how blind people see data. I'm sure that you're aware that visual data is everywhere, from news articles to scientific papers. It represents a big, large majority of information conveyed to sighted people. So the thing is, right, what if you can't see that data? How do millions of blind and visually impaired individuals access this crucial information? So the problem here is that traditional charts are obviously based on your vision. So let's say for a second you imagine like a line graph, right? It goes up or down depending on whether the numbers go up or down. And visually that makes sense, right? And sometimes when it's above like a certain threshold, it'll be green, and when it's below, it'll be red, right? So it makes it very easy to see when the numbers are good and when the numbers are bad, and this is very easily conveyed to somebody who can see. Even with bar charts, they might represent a survey, where it will show 47% of people or 62% of people or whatever, and it'll be represented by different heights in the bars. Same things with pie charts, etc., etc., etc. So if you can't see these, obviously this creates a very significant barrier to understanding and participation in a data-driven world. So today, we're actually going to be talking about the fascinating and innovative world of accessible data. We're going to talk about how blind people engage with charts, moving beyond more purely visual representations through technology, sound, and touch. So we're actually going to talk about screen readers, which you're probably familiar with. And if you're not, screen reader is just something that lets somebody who can't see tell what's on their screen. We're going to talk about sonification, which is making the data into a sound form. And then tabularization, which is just displaying the data in an actual table. And another slightly different one, which is not digital, that's physical or embossed charts, which is a whole other category, but something that I thought would be very interesting to talk about. So the first topic that we're going to talk about here is screen readers. So the kind of base problem here, right? So, charts are generally images, right? So, for example, a JPEG or a PNG. So these are completely inaccessible to screen readers. And a screen reader will often just say image or graphic, leaving the user completely in the dark. So obviously, there's a really common frustration here for screen reader users. If you encounter a chart that has no alt text or a description, then how are you going to know what's actually going to be in it? So the ideal scenario here, there's a few actually, and we'll kind of run through them. So if it's just a picture of a chart, obviously adding good descriptive alt text for charts. So for example, you might think just putting bar chart there is alt text, but it's not really, because that actually doesn't tell you what's in it. So for example, you would say something more like bar chart showing sales figures for Q1 2025 across 3 products. Product A at $10, product B at $15, and product C at $8. Product B had the highest sales. So that right there would be good alt text, right? That will easily convey what is in the diagram or the chart to the user, and means that they're not missing out on anything by not being able to see the image. Obviously, if you had more complex charts, for example, you might use different semantic HTML or ARIA attributes. So you'd be able to expose different chart elements to the users, for example, the axes, data points, and legends. So that will allow people to then navigate to different parts of the charts. So as part of this as well, you will generally use a library, for example, HighCharts, which actually has an accessibility module built in, which is really great. And that's actually kind of how I learned about some of these features. For example, Sonification, I had actually never heard of before I came across HighCharts. Now, generally, height charts, and even if you're making your own charts, you want to use a data table as an underlying source. Now, this is really crucial because many accessible charts actually have an underlying hidden data table that screen readers can often access and navigate. So this allows people to navigate the raw numbers a lot easier. Now, the problem here is that the reality here is that this ideal is not met. So the majority of websites still lack proper alt text for images, like just regular images, forget complex data visualizations. So obviously this means that if people aren't going to be adding alt text images, then they're definitely not going to be adding it to different diagrams and charts. So screen readers are probably a no-go for a lot of people in terms of experiencing charts, not because they don't work, but just because a lot of people aren't actually making their charts accessible. And even if you do use a library like HighCharts, the accessibility isn't turned on by default. You actually have to go and include the module yourself, and then, for example, with certain things, you will actually need to sort of set it up in the configuration yourself, which a lot of people sadly won't do. Now, next up here is sonification. So this is more so listening to data. So it's the use of non-speech audio generally. Now, you can use speech as part of this, but generally it's things like sounds, tones, and rhythms to convey information or data. You can kind of think of it as painting a picture with sounds. So, for example, right, you'll map different data parameters to sounds. For example, higher value equals higher pitch, increasing trend equals increasing tempo, etc., etc., etc. So, okay, let's say here you're looking at a stock market trend. A rising pitch indicates an increase, while a falling pitch indicates a decrease. So essentially what that means is as the stock goes up, the pitch would go up, and as the stock goes down, the pitch would also go down. Bar charts, different tones and or different lengths of sounds can represent different bar heights, perhaps with a distinct sound for each category. Scatter plots, these get a little bit more complicated, so individual data points might be represented by distinct clicks or panned sound across stereo fields to indicate their position. And that will also generally be used with charts, is as it kind of moves across the line, for example, if it's a line chart, it will move from left to right in your ears, so the sounds are like stereo. Some systems actually have interactive sonification, so you'll be able to explore a chart by moving the cursor and hearing the data points actually as you move through them. Now, sonification is really great because it can provide a quick, holistic overview of trends and patterns to allow you to grasp the data very quickly. It can be surprisingly emotionally evocative, enhancing memorability, which is really, really good. So there are a few challenges though. It can be difficult to extract precise numerical values, often requiring other methods to get the exact figures. So sonification isn't generally used by itself. You would use sonification to get a quick overview of the data, and then you might have a look at some of the individual figures yourself. So you'd go and look at the high points and the low points to kind of understand and get context as to where those other pitches may map to. This would also require a learning curve, especially for complex data. Obviously, if there are multiple sounds, which sometimes there are to represent different kinds of data, then you would need to understand exactly what's going on. There's also a potential for cognitive overload if it's not designed very well, especially for complex data sets as well. So I'm going to play for you an example here of sonification, and it's just 10 notes, so it's nothing too crazy, and it's a relatively simple data set, but it's just to give you an idea of what you could be expecting. That right there should give you an idea of how sonification works. Now that we've gotten that out of the way, let's move on to the next way in which we can experience charts. Now, the next one is more of a traditional form of kind of understanding data. So, this is more so about data in rows and columns, or tabularization. So, this will kind of cover the power of tables. For many blind individuals, a well-structured data table is often the most efficient and preferred way to access detailed chart data. So, I mean, why are tables so effective? Screen readers are exceptionally good at navigating them. Users can move row by row, column by column, and will be able to access precise values at their own pace. So, let's say, for example, you give me a chart, right? And it has date, and then it has, let's say, different ratings that you could give the restaurant or whatever, right? And so you'd have, a column for 1 star, 2 star, 3 star, 4 star, 5 star, and then we'd have an average column, right? So if I was using a screen reader, I could just navigate to the average column and then go down, and I would kind of know, okay, well, this is for, June. So I'd know this is June 1st, June 2nd. On June 1st, we got an average of 3.6. June 2nd, we got an average of 4.5, and you can go down each row by row there, but just focusing on that one column so that you can really understand the data that you're looking at. So, a lot of good data visualization tools will include a button, for example, let's say view to data table, or have it embedded above or below the chart. And you can see that with high charts. I think it's export data is what you need to include in terms of modules to be able to actually view the data table, which is really, really handy because then you can just view it on the page, and it also lets you download it as well as a CSV. So obviously for this to work, you'll actually need to have clear column headers and also proper table markup. Now, thankfully, things like high charts do have that, but and it will kind of make sure that you're kind of following those procedures, because otherwise your chart would look weird because your labels on your chart also wouldn't be very good. So now this has a good benefits because it allows for precise data extraction. You can get every exact number, as I kind of mentioned earlier. You can just get the exact data that you want, and you're going to get the exact numbers. Whereas with Sonification, you didn't have any idea what any of those numbers were. So it's easy to compare specific values or find out whatever it is that you need. It offers a familiar and reliable navigation method for screen reader users. Now, however, it does have a few limitations. So it may not immediately convey overall trends or patterns effectively as a visual chart or a well-designed sonification. It can be overwhelming or time-consuming for very large datasets if you're trying to spot a particular trend. So obviously that's really important there, because if you have 100,000 data points, you're never going to be able to look through that in a table. And that's where things like sonification can really, really come in handy to give you an overall idea of the data. And then you can maybe kind of, if you drill down, if you will, on the individual data points that you want to look at. Now, generally, we focus on more digital experiences here on the podcast, but this one will talk more so about tactile graphics. So, when I say tactile graphics or embossing, essentially what that means is creating raised representations of visual information that can be explored by touch. It's about literally putting the data at your fingertips. So there's different ways of doing this. You can use emboss paper using braille embossers, swell paper using microcapsule paper, 3D printed models, and also other tactile materials. So how it works. Emboss charts use specialized printers called braille embossers, which create raised lines for accesses, texture areas for bars, or distinct dots for data points on a graph. And then swell paper or microcapsule paper. This involves printing on special paper with black ink, then passing it through a fuser that heats and raises the black areas, creating instant tactile shapes and lines. 3D printed charts. Now, this is much more of a modern kind of approach, and what this will let you do is create actual 3D models of bar charts, scatter plots, or even topographical maps that can be explored. This kind of more helps provide more depth and dimension to data, literally, because it's 3D printed. It's more of a 3D approach. Whereas the others, although they are technically 3D, it's still in more of a 2D view, if you will. So the benefit to this provides a direct, tangible representation of the data, allowing for spatial understanding. It can be highly engaging and intuitive for some, offering a different modality for certain comprehension. Excellent for teaching and long-term reference as well. So some of the challenges. Generally, the cost can be very high because you need specialized equipment. A quality braille embosser or 3D printer isn't necessarily very cheap. Portability can be an issue for larger or more complex charts as well. You're also limited by the size and complexity that can be effectively represented by tactile, because too much detail becomes confusing by touch. It requires clear accompanying braille labels, legends, and often a spoken description. For example, tactile atlases, scientific diagrams, and mathematical graphs can be produced in this way. Now, I personally really like this, and I think it's very cool. I do generally think this is, although probably the best approach, also the worst. It's the worst just because, as I kind of mentioned, you have to bring the charts around. They're not as portable and they're physical. However, I feel like they do also let you get the best understanding, possibly the quickest. It's kind of like the intersection between using a table and sonification, because sonification doesn't let you find out the exact values, whereas these more tactile charts can. However, you also don't have to scroll through a whole table, and you can also see the trends, well, feel the trends, if you will, very easily. So I feel like this is a good approach. I do wish there was maybe a better way to do it. However, this is a pretty good approach, and in my opinion, it's very, very cool. Now, the thing you might be wondering is, okay, what about the future? So, okay, the multimodal approaches are generally the best, because this will let you give choice to the user who may have a different kind of want. A digital chart with an underlying data table, an option for sonification, and perhaps a downloadable file to create a physical model for those who prefer tactile exploration. So this means that everybody gets to have what they want. If you want to explore it with your screen reader, you can. If you want to listen to the sonification, you can. And if you want to look at the data table, you can, etc. You can download the file, and you could also print it if you wanted. So this is generally the best approach. And if you use something like high charts, you need to include the correct modules to make this happen, but it's super easy, which is why I recommend not necessarily creating your own solution for this and using a pre-existing library, because generally speaking, it will probably be better if you just use what they give you. So yeah, I mean, essentially what it boils down to is the correct approach is none of them. It's all of them. Because you should be giving people the choice to kind of choose what they want. Because with sonification, for example, I like it for when it's a really large data set, so I can understand what's going on. But if there's just a few data points, then honestly a table or just the interactive chart with my screen reader would probably work fine. Now, AI and machine learning is something that obviously we should be talking about here, because AI could be generating really descriptive alt text for complex charts, or even designing personalized sonification schemes based on user preferences, which is really, really interesting. Because currently part of my problem with sonification is the person who made the chart may not necessarily like the sonification the way that I might like it. I might like certain things emphasized, certain things not emphasized. I might like speech in my sonification, I might not, and they obviously have no way of knowing that. Now, the thing to really consider here is that the design here should definitely be user-centered. The most crucial element is involving blind users in the design and testing of accessible chart solution in the very beginning. Nothing about us with us. So again, important really to kind of involve the people that you are building things for in the process of building them. Obviously, for developers and designers, prioritizing accessibility from the outset rather as an afterthought, because it's really easy to build something with accessibility. It's very hard to go back and then bolt it on later. So, in conclusion, here we've kind of explored different ways that blind individuals are seeing data through the power of screen readers, sonification, the precision of tabular data, and the tangible reality of embossed and 3D printed charts. So, as I've mentioned, accessibility in charts isn't just about compliance, it's about empowering individuals with information. So this just means that everybody gets included and everybody has an equal opportunity to understand the world around them, which is obviously really important. Definitely be encouraged to check out HighCharts, check out their Sonification studio, which is actually how I made the demo for this particular episode, and make sure that you, if you are sharing any charts or anything like that, that they are accessible. Try your best to support designers and people who are helping out with making charts accessible, like HighCharts, for example. So in your next project, maybe look into HighCharts if your current solution isn't accessible. That is going to be it for this episode of the Envisiontech podcast. As always, I've been your host, Paul Gagan, and I will see you all next week.